morning children. How are you? Have you watching the videos? Very good. So welcome back to our session. What is the topic it is going on? Electric current and its effects. So in the last class we have learnt about heating effect of the electric current. Is it children? Some of the devices like electric heater, electric stove, about the bulb we have seen. Is it? Yes. Today let me talk about fuse. Have you heard about this fuse? Where it will be? In our houses, at the outside, the main board. Fuse board only it will be the separate. So that is the main to give the electricity to our home. If anything happens, that fuse wire will be melted. Actually that fuse wire is made up of aluminium, tin or the lead. So that much easily it won't melt. If it comes excess of power, excess of current, means it is going to heat up and only that fuse device will be melted. Inside the electric devices it doesn't happen anything like that. It protects our gadgets at home. It's the main thing for us. Then let me see what do you mean by the fuse. An electric fuse is a safety device used to prevent damage to an electrical circuit when excess of current flows through it. It's very good, no? See, an electric fuse, it is one of the safety device which we are going to use to prevent the damage to an electrical circuit when excess of the current flows through it. It is the fuse. Have you seen the fuse, children? Yeah, I can show you the picture of the fuse. Now I think you got the idea about that. So immediately see in your house where the fuse is located. So that is the fuse. And next thing, let me talk about MCB, children. What is this MCB, ma'am? Yeah, let me know about the MCB. What do you mean by the MCB? Miniature circuit breakers. What's that? Miniature circuit breakers. You can see, children, in the room we call it as DPs. So one will be in the blue or black color, one will be the red color. If any excess of current comes in, automatically itself that switches comes down. Okay. So these are the switches which automatically turn off when current in a circuit exceeds the safe limit. So when the high power comes means, simply we call it as the DP that it will be. So without our knowing itself it is going to comes down. That is only we call it as the MCB. Okay. So I can show you the picture, children. If you are not getting the idea, I can show you the picture of that MCB. See. So this is about our fuse. Okay. So about this fuse, watch a small video. After watching, let me come back for the next topic. Okay. Watch the video, children. We are talking about the electric fuse. Electric fuse is the weakest part in the electric circuit which results in melting and hence breaks an electric circuit in use. Have a look of the parts of electric fuse. This is the fuse here. An electric fuse consists of a solid Brooklyn grip on the sides of which there are rectangular clamps of copper. So these are the copper clamps. These clamps tightly fit in the terminals T1 and T2. You can see in the picture. In between the copper clamps, a fuse wire is fixed which is made of solder. So 60% tin, 40% lead. Solder is an alloy of 60% tin and 40% of lead. If a fuse wire has more thickness, it can withstand more electric load and vice versa. You can see that the thick one. When the grip is inserted, In the casing, the terminals T1 and T2 get connected to each other through the fuse wire. So here we are having the fuse wire. You can have a look. So reasons for melting of the fuse wire. Following the reasons for melting of fuse wire or when the circuit gets overloaded due to the large withdrawal of current, the fuse wire melts. This is turn breaks the electric circuit and hence current stops flowing in the circuit. In this way, a fuse helps in disconnecting an overloaded or faulty electric circuit and hence prevents an electric fire. Next, let me go for magnetic effect of electric current. Magnetic effect of electric current. Here itself, we are having the message, is it? So, by using of the magnets, we are going to produce the electricity. How? Let me see. When an electric current passes through a wire, it behaves like a magnet. Is it? Let me know about that. When an electric current passes through a wire, it behaves like a magnet. This magnetic effect of electric current is known as electromagnetic effect. Super, very good. Is it? Yes. So, this magnetic effect of electric current is known as electromagnetic effect. Wow, very good information for us. Is it? Yes. This was explained. That means this was discovered. This was discovered by Christian Ørsted. Who is he? Christian Ørsted in the year 1820. So according to him, if the direction of the current is reversed, the magnetic field also get reversed. This is super, still super. So not only in the straight way, if we are going to reverse it once again, that also is going to reverse it. If the direction of the current is reversed, the magnetic field also get reversed. So, this is the magnetic effect of the electric current. Let me see another definition for this. The magnetic effect of electric current is also known as electromagnetic effect. So, the magnetic effect of electric current is also known as electromagnetic effect. It is observed when a compass is brought near a current carrying conductor, the needle of compass gets deflected because of flow of electricity. Why it is going to deflect? Because of the flow of electricity. This shows that electric current produces magnetic effect. Without the magnets, we can produce the magnetic effect by using of the electric current. So, this is about the magnetic effect of electric current. So, for this, let me see one small video recording this. Okay, children? Yes, see the video and let me come back.
Is electricity and magnetism are related? Let's try to understand this with an activity. Here, we have taken a cardboard tray. It is wrapped with an electric wire. A small compass needle is placed inside it. The free ends of this wire are connected to an electric cell through a switch as shown. Note the direction in which the compass needle is pointing. Now, switch on the circuit with a plug key and observe the compass needle. We can see that the compass needle deflects. Now, unplug the key and observe. We can see that the compass needle come back to its initial position. Repeat the experiment few times. We know that compass is a tiny magnet which is affected by any magnetic field around it. In this activity, we have seen that the compass needle gets deflected when the current flows nearby. This means that there is some magnetic field created around the compass when current is passing through. So, when electric current passes through a wire, it behaves like a magnet. This is the magnetic effect of the electric current. Thus, we find that electricity and magnetism are related.
Have you watched the video? I think now you got the idea about that. That means the electric current produces the magnetic effect. So we were talking about the Ørsted. That means this was covered by the Christian Ørsted. So his discovery also, let me see through a small video, and I can show the picture of the Ørsted also, children. You can watch. So by this, let me end up today's session. Tomorrow, that means next class, let me meet with a new topic. Okay, thank you, children.
Ørsted's experiment. In 1820, Hans Christian Ørsted performed a simple experiment and discovered the magnetic effect of electric current. The experimental setup, similar to the Ørsted's experiment, which led to the discovery of magnetic effect of electric current, is shown in the animation. A conductor or conducting wire AB lying in north-south direction is connected to a battery V through a commutator or tapping key K and rheostat RH. A magnetic compass needle NS is placed just below the conductor AB. Initially, when no current passes through the wire AB, the magnetic compass needle shows no deflection. When an electric current passes through the wire placed above the compass needle, the magnetic compass needle got deflected from its normal position, which is along north-south direction. On reversing the direction of electric current through the wire, he observed that the magnetic compass needle got deflected in the opposite direction. Also, the deflection of the compass needle increased when the magnitude of electric current through the wire was increased or when the compass needle was brought closer to the wire.